All right, so you'll notice on the study guide that you have some terms you have to know. These terms should all be in your handouts that you had already. They are also in your books if you happen to miss them when we were going through them on the guided notes. Along with that, you need to kind of be able to not just define, so recognize those definitions, but you also need to be able to tell me what's the difference between distance versus displacement. What's the difference between speed versus velocity? Examples of scalars versus vectors. Remember, basically speed and velocity are a good example. Speed would be a scalar, velocity would be a vector, because you'll have direction when you have a vector, right? Versus just a number, just like a speed, average speed. All right. Whereas velocity is going to give you a positive or negative. Acceleration is going to give you a positive or negative, right? And so being able to tell me those differences and give me maybe examples of those. What do we mean by average versus instantaneous? What do we mean between positive and negative velocity or acceleration? What do those things tell you if you have a positive or a negative of those? Slope of the tangent line versus area under the curve. So as you're moving from position to velocity, your slope of your tangent line tells you your velocity. When you're looking at velocity and time, the slope of the tangent line tells you your acceleration. And then the area under the curve goes backwards. So the area under an acceleration curve tells you your velocity. The area under a velocity curve tells you your displacement. All right, so think of the slope of the tangent line as taking you forward from position to velocity to acceleration. And area under the curve is taking you backwards from acceleration to velocity to position. Okay, that's all that I want you to understand with those. Free fall, you will have to understand free fall, which means you will need to know gravity. That was not on your little list that I showed you. Gravity is negative 9.81 meters per second squared. So that's what I want you to always use for gravity. And then you will have word problems, okay? And so the word problems will be just like it was from your homework, and it will be just like all the ones that I've given you here. You do have an answer key attached. I tried to make sure that all the significant digits were correct, right? So I went back through and made sure I put a decimal where I wanted a decimal. If you have a question about how they got a number or how they got the number of significant digits, let me know. All right. But most of these are going to be pretty straightforward. As you go through these, you're going to want to remember your little symbols, right? And so the key things you're going to think about here is, I need to know if they gave me a change in time. I need to know if they gave me a change in position. I need to know if they gave me a final velocity or an initial velocity. I need to know if they gave me the average acceleration. And so those symbols are extremely important, that one, you know what they mean, and two, that you recognize them in your word problems. Because if you can do that piece of it, you can do any of these word problems, all right? And so what I would recommend is that as you read your word problems, you label what they've given you based on those symbols, Key words that you're looking for: rest. At rest means it's not moving, right? Comes to a stop means up. They just told me 0 velocity, right? Falls up, probably in here, I'm going to use gravity somewhere. All right, does that make sense? And so between the word problems from the homework that we did and the word problems on here, you're going to get a really broad range of potential problems, right? And so they're not all going to be the same. You're going to see as you work through these, they're not all the same. Some of them are very different. All right, so number 2 here says a bus is moving at a speed of 20 meters per second when it begins to slow at a constant rate of 5 meters per second squared in order to stop at a bus stop. If it comes to rest at the bus stop, how far away was the bus from the stop? All right. So a couple things here. They give me some information. Moving at a speed of 20 meters per second. What did they give me? Of all my little notations, what did they give me? So here they gave me initial velocity there. At a constant rate, it begins to slow down. That's important. At a constant rate of 5.0 meters per second squared. Units help me here. What is that? And so when I write this acceleration and I am slowing down, what do I need to make sure I put in front of that acceleration? a negative. In order to stop the bus, what did they just tell me with those words there? They told me my final velocity is going to be 0. Remember, 0 is not measurable, right? So you don't have to worry about 0 with significant digits, okay? It said if it comes to rest at the bus stop, how far away? What am I looking for? My change in x or my displacement here. How far away is what I'm looking for. So you'll notice when you use formulas that I don't have time here. Did they mention time at all? No. So that lends itself to my third set of equations, right? That lends itself to my third set of equations, which is what I'm going to use. I'm going to use the equation that says change in x is going to be my final velocity squared minus my initial velocity squared over 2 times my acceleration there. I'm going to use that one. And by the way, before this whole section is over, you're probably going to have him memorized without a formula sheet because you use that a lot. All right? So now I'm just plugging in what I know. I know my final velocity was 0. I know my initial velocity was 20 meters per second squared. Not per second, whole thing squared, by the way. All over 2 times my acceleration, which was negative 5.0 meters per second squared. So just so you know, we have, when we do this, the top ends up being negative 400. We squared the meters, we squared the seconds. On the bottom, we get negative 10 meters per second squared. Remember I said you can cancel denominator to denominator, and numerator we cancel one of those m's, which means we're going to get just meters, and we're looking for a distance. That makes sense, right? 400 divided by 10 is going to give me 40. How many significant digits do 2 significant digits, and it's a 40. How do I indicate that's 2 significant digits? I can put a decimal. One of the ways you'll also see it is sometimes they will make an underline. Like if I had 400 here and I needed 2 significant digits, they will underline the second 0 to indicate that is my significant digit spot. By the way, if you ever see that, 40 meters is how far I moved. So the question is about the units. When I squared that, I squared the m and the s. So I got the negative in front, the 400, and I had an m squared and an s squared. On the bottom, acceleration is already meters per second squared. Only my seconds are squared there. So I got negative 10, and I had 1 meter and a second squared. When you have a fraction over a fraction, you can cancel numerator to numerator, denominator to denominator. So the denominators were squared and squared. Those all canceled. My numerators, I only had 1 here, so I could only cancel 1 up here, which left me with meters, which in my brain says I'm finding a displacement, which should be a measurable length. All right, number 3 says a block starting from rest slides down the length of an 18-meter plank with a uniform acceleration of 4.0 meters per second squared. How long does the block take to reach the bottom? So we're going to label this starts from rest. What did they just tell me with that starts from rest? Initial velocity, which equals 0. Slides down the length of an 18-meter plank. What did they just tell me there? My change in position there was 18 meters. And then they straight up told me what this is with a uniform acceleration of 4.0 meters per second squared. They told me my average. Solving for how long? What are we solving for? Change in time. All right. So for this one, I had to think about, all right, I know my change in position. I know initial velocity. I know acceleration. I don't know time. All right. And so if you look at your second equations, you're going to have to use an equation that uses time because that's what you're solving for. Does that make sense? And so I used this one. Again, you may see a different way to do this. And that is perfectly fine as well. I use this one. The reason is because my initial velocity zeroes this out. If I didn't use this, if I didn't have an initial velocity of 0, I would actually have a quadratic that's formed. This technically is a quadratic, but I can go straight to square roots here. So it's possible that when you're solving for time, you're going to have to use the quadratic formula like we did in that one crazy one. In this one, you don't, because when I start plugging stuff in, 18, that goes here. My initial velocity is 0, so it's going to zero out this little set right here. Plus I have 1/2 times my acceleration. And I am solving for my time, but this guy is squared. So when I simplify this, this part goes away. All right. I get rid of this. You can just simplify those. 1/2 and 4 is 2, right? What do I need to do with that 2? Divide both sides by 2, right? Divide by 2. Divide by 2. All right. By the way, just so you, for those of you that are paying attention to units, 18 divided by 2 is 9. If I have meters divided by meters over seconds squared, and you keep change flip, you get meters times seconds squared over meters. You're left with just seconds squared. Does everybody see that? Seconds squared is going to equal my time squared. How do I solve for my time then? Take the square root of both sides. Technically, the square root of both sides is positive and -3. One of these doesn't make sense. What doesn't make sense? Time travel doesn't make sense, right? So we can't go back in time. So we're going to say it took 3 seconds. How many significant digits do I need to use with this 3 seconds? I need 2. 18 and 4.0 are my given measurements here. So 3.0 seconds right there is my answer.